All right, I wanted to do one last example of trig substitution to show you all, and hopefully this helps out. So the integral I'll look at in this video is the integral of x cubed times the square root of 4 minus 9x squared dx. So you look to the square root to tell you how to build your triangle. And so when you have a square root, it's like either a squared plus b squared or c squared minus b squared. And so here I'm thinking of it as c squared minus b squared. So this is 2 to make it c squared equal 4 minus b squared, so minus 3x here, because 3x times itself is 9x squared. And this other piece becomes 4 minus 9x squared. So when I look at this triangle, the way that I constructed it, I can say sine of theta is opposite over hypotenuse. And I can say that cosine of theta is adjacent over hypotenuse. And that's going to be pretty much all I'm going to need to use to solve this problem. So if I rewrite this expression, I get 2/3 of sine theta equals x. In other words, taking the derivative, 2/3 cosine theta d theta is dx. The cosine theta I'm just going to multiply by 2. So 2 cosine theta is root 4 minus 9x squared. So then I can substitute those back into my integral. So x cubed is 2/3 sine theta cubed. The square root is 2 cosine theta, and dx is 2/3 cosine theta d theta. Now let's move all those constants to the front. So I've got 2 to the 3rd power, to the 4th power, to the 5th power. So that makes 32. And then on the bottom, I have 3 to the 3rd power and another 3, so that makes 81. Now on the inside of the integral, I have sine to the 3rd theta times cosine squared theta d theta. Okay. So when you've got sines and cosines remaining, you want to break it down so that you could do a u substitution. And when I see an odd power of sine, I know that I can use the fact that sine squared theta plus cosine squared theta equals 1. So I know that sine squared theta can be replaced with cosine squared with 1 minus cosine squared theta. So I'm going to break this apart here to be sine theta times 1 minus cosine squared theta, because if I take one of the sine thetas out, there's a sine squared left over. And then I have another cosine squared theta d theta. And the beauty of doing that is now you can do a u substitution, where u is cosine theta. So du is negative sine theta d theta, and that would cancel out the sine theta at the front. D theta is du divided by negative sine theta. So if I substitute everything in, I'm going to kind of move over here. I've got 32 over 81 integral sine theta 1 minus u squared du over negative sine theta. So cancel out the sine thetas. Let's write everything in terms of u. I'm going to bring the negative out front. So now I have u squared minus u to the 4th du. Take the antiderivative, u to the 3 over 3 minus u to the 5 over 5. Now I'm going to plug u back in. So u is cosine theta. So cosine cubed theta over 3 minus cosine to the 5th theta over 5. Then I remember that cosine is equal to this expression from my original triangle. So my final answer is negative 32 over 81. And then I have 4 minus 9x squared raised to the third power. So that would be to the 3 halves here. The 2 on the bottom got raised to the third power, so that's an 8. With the 3 already on the bottom makes 24. Then I have another 4 minus 9x squared. This one's raised to the 5 halves. So the 2 on the bottom gets raised to the 5th. 2 to the 5th is 32. There's a 5 on the bottom already. So 32 times 5 is 160. I think that's right. And all of that plus c. And that should be good. And if you took your derivative, you should get back to the original integrand. All right, please comment if I made a mistake or if anything was confusing. Ask questions. Thank you.